we'll work around it.
Yeah. Professionals.
Tell you what. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 262, Wheelchair Hacking, Big Little Science at Home, and Arya Talks PCBs. This week in the news, no news is good news, so I'll just give you two quick Hackaday reminders. One, the home automation contest is ongoing, so if you have anything you'd like to enter, head on over to IO and pull down the little pull down to get your project entered in the home automation contest. And the other is that Hackaday Europe is upcoming shortly. I guess it's just about a month to go, April 12th through 14th in Berlin. We just selected our speakers and workshops this week, and we'll be announcing them next week, so stay tuned. I guess we'll announce workshops first next week, probably Tuesday. So if you are attending and want to look for workshop tickets, hit Hackaday up early and often. And if you are waiting until you see the speakers list, A, don't do that, just go. But B, most of the tickets are sold out now. We have, I think, like 80 spots left. So if you want one, strike while the iron is hot. Oh, and if you don't know about Hackaday Europe, it is a kind of 1.5 day, almost 2 day conference in Berlin. We'll actually be going out on the Friday night, going out for drinks, and then Saturday begins in earnest with a full day of talks and workshops, and we're actually going pretty late with the talks, but we've got the venue booked until 2 in the morning, and we've got music all night, so it's going to be a good solid full day on Saturday, and then Sunday is kind of a relaxed chill out day. We got brunch, we've got lightning talks all day. Sunday is a good, recovering from Saturday type day. But I love lightning talks because, everybody there wants to get up and give like a 5-minute talk about what they're up to. And some real gems come out of that too. So basically, it's all bring stuff you're working on, bring stuff you want to show off. The crowd is awesome and the talks are really good. Streaming we're still working on, but anyway, if we don't get them streamed, we at least will have them recorded and we'll put them up as soon as we can up on Hackaday.
I like that idea of a Sunday kind of chill day.
It's actually really nice.
Yeah, versus the SuperCon full throttle until you pass out Sunday night method of planning.
Yeah, SuperCon's kind of evolved into this like pre-chill out day on Friday though. Like we used to open the doors way late on Friday. It first started with we'll open up at like 5 p.m. to get people their badges if they want to start working on them Friday night. And then we're like, the badge hacking day where there's no talks is actually really fun. And so we just pushed the time earlier and earlier. And now we open up at like 9 o'clock in the morning on Friday. That's really fun too. So the Europe one is kind of the mirror image of that. The chill, relaxed day is on Sunday.
This is a journey into sound.
What's that sound?
What's that sound?
Let's move on to What's That Sound?
Oh, boy.
This week is a Pick the Winners week. Christina Panos listened to the sound last week, gave it her best guess. Now's your chance, Tom, if you want it.
All right.
You're another poll.
Oh, wow. Didn't expect the man to yell in my ear.
Kaboom. What do we got?
I don't know. It's funny. The guy talking has put me so off my game. I would have, it sounded like a little mechanical thing, but there's clearly some person there doing it. I don't know. Sounds vaguely like printing pressy kind of early on.
Yeah, you got that mechanical vibe, right?
I don't know. Unless he's like loading a cannon or something. Loading some naval cannon, but.
That is funny. I went looking online for one of those old adding machines, and I found this one of My Antique Burroughs Adding Machine is the name of the video. So it's an old mechanical calculator, but the video is him demonstrating it, and he's like, and so you type this number in, and then he's like, booyah, and then he's like, type, and he's like, chunk, and he's, it sounds like he thinks he's loading a cannon, but he's actually adding 2 3-digit numbers.
Yeah, only shots fired are in the accounting department with that.
Correct. It's funny you say printing press. A number of people suggested it was a printing press. Probably the first most popular wrong answer was a credit card imprinter, which Standback Burrito claims is called a zip zap machine. I like that.
I'll believe it.
Yep.
We definitely have to use that as a sound, but we have to wait a while.
Yeah, this is the problem is I get some great suggestions from people's wrong answers. Like, I love that. Printing press, of course, was the other one. A typewriter? Maybe, but we got a couple of those. But 7 people said an adding machine of one kind or another, mechanical calculator, mechanical adding machine. These are all right answers because that's what this thing was. So let me see. I need a random number between 1 and 7. I am actually traveling. I'm on the road. I don't have any dice. We're doing it the old-fashioned way, computer random numbers.
Traveling without your die? That's such a sin.
Traveling without my wife's dice bag, which is what I usually use. All right, here we go. I'm using my random hash function, which takes a file on my hard drive, hashes it, and then does it modulo however many I tell it to. I'm doing it on the make file that I use to make the podcasts, actually. So this is on a make file that I haven't ever used before. So this number is new to me, and it is syntax error. Hold on a second.
Congratulations, syntax error.
What do you mean syntax error? Number contestants file name, not file name number contestants. Silly Elliot. And the random number is 5. Sweet. So congratulations to Baldo9256, Mechanical Adder. You're correct. You got picked. I'll get in touch with you, Baldo, and we'll get you the t-shirt shortly. Everyone else out there, listen next week. We'll come up with a new sound. You'll have a chance to guess it and take your shot at winning a Hackaday Podcast t-shirt.
I'm pretty sure I actually have one of those credit card machines now that I think about it.
Do you really? Oh, you have to record it for us.
I know I had one at one point, and I just can't remember if I finally threw it away or I don't even know where the hell I got it from now that I think about it.
That's awesome.
Swap meet or something.
Do they still even use those? I haven't had one of those used in a million years.
I do seem to remember like when Sandy hit here in the Northeast and some places were like totally beat and they had no power. I remember there being like a kind of a short-lived resurgence of that because it was the only way they could take card payments.
Oh, that's awesome. All right. My first hack this week is, let's start with the controversy. The insurance buys the wheelchair, but not the app to run it. This is the story of some wheelchairs made by the German company Alber and sold through another Dutch company that I can't think of the name of right now that requires its users to buy an extra for-pay app to access some of its functionality. And this, of course, has rubbed a whole bunch of people the wrong way. To be partly fair, the app doesn't control anything that's super mission critical. It lets you see the battery status on your phone. I mean, I guess that's important, of course, but it also shows the battery status on the physical wheelchair itself. So, you can have someone check the battery status. It's not a problem. But it also has like a cruise control function and some other things that apparently the wheelchair community that is linked in this article are pretty bummed about not having access to. And so there's a lot of talk about how to hack this app, how to get into it. It's also worth exercising a bit of caution here because a wheelchair is kind of a safety critical device, right? But reading through the forum post we linked to, which is a lot of wheelchair users on a hacker forum, most of them are pretty angry about having this functionality taken away from them. Jenny does kind of caution against hacking on this because it is kind of a medical device and it's important that it be safe for the user, etc. The defense of Alber here is that none of these are absolutely critical functions anyway and that they're only making you pay for the frills. So I think the don't hack on this because it's a medical device when you're only hacking on the frills kind of falls apart. I don't know. What do you think, Tom?
I mean, first of all, I don't want to say what is and isn't, a necessary feature for these individuals.
For sure.
What might to us seem kind of unnecessary. I mean, it could be a huge thing for their day to day. I saw one of the comments say like, apparently if you pay for the premium package, which is it is so so disgusting that it's called like the premium package. It's called like mobility premium or something horrifying, and
Dude.
you know, like you can't make this stuff. Oh, the mobility plus package. Oh man, talk about some dystopia. But if you don't pay for the mobility plus package, apparently like limits the speed of the wheelchair. And that just seems so evil. You know what I mean? Like, and if this is your way of getting around, right? And you could go faster, but you're not allowed because you didn't pay.
Oh, that's horrible.
You know, like that's pretty rough. I mean, yeah, okay, it still works. Like I guess that's the takeaway, right? Like the wheelchair still works, but like to put stuff like a speed limit behind a paywall is just, you know. And somebody else commented there is an ability to remotely operate it, which is important if you're in a different part of the house than the wheelchair is, right? If you want to bring the wheelchair to you so you can get into it. So I guess you could make the argument that, you know, these are the high tech features that maybe weren't available in previous generations, but still, it's crazy to kind of prey on these people. Really, you know, you give them the wheelchair and say, "Oh, here you go, everything's fine," and then they start looking through the abilities of the thing, and like, "Well, wait a minute, I can't do that, you know." And it seems like, did you say it's, from what I'm reading here, it's $300 for the package,
for the app package,
and apparently that's yearly too.
Oh, fuck.
So it's like a subscription. Like, man, that's a. I mean, I can tell you right now, I don't pay $300 a year for any subscription service. You know, I have. That seems like highway robbery, even if it was moving me around. Like that's a lot of money to ask of people. So yeah, I can certainly see why people would be upset about this, and why this certainly seems like one of those, you know, righteous hack moments, right? You put some kind of arbitrary, and this is truly arbitrary. You know, you put an arbitrary limit in front of somebody, definitely is negatively impacting their day-to-day life. It's not a surprise that people are, you know, clamoring for a fix.
You know, especially this group, right? Like, if you're at a wheelchair company, can you imagine being like, you know, let's not do everything we can to make this the best experience for people using this wheelchair. Let's hide some of these features from them and see if we can make them pay more. And then you're like, oh, they'll totally pay more. In fact, they'll pay a lot more because they're desperate, because this would totally increase their quality of life. So we could squeeze a bunch of money out of them.
It's really pretty evil, I gotta say.
Couple readers wrote in worried that this was going to be a legal issue for people to hack on this. And I don't know. This is like one of those totally gray areas. There are cutouts in the Digital Millennium Copyright Act for interoperability and for making sure that features of devices, and actually it's been tested in court, especially with medical devices, are safe and usable even after things like, you know, the cloud service goes offline or whatever. So there's actually a lot of precedent for legally hacking on medical devices and for doing it on general devices for interoperability reasons. I don't know how this fits with this. I'm totally not a lawyer, certainly not an international copyright lawyer. I don't know what the legality of working on this would be, but I think it's fully in a gray zone.
Well, I gotta say, if I was one of these people, I'd love the company to try to then, you know, sue me.
Yeah, right.
And to take that to court and have me come in and explain what you've done and see who's gonna feel sorry for the poor medical company that was fleecing the wheelchair users.
Yeah, good luck with the PR disaster on that one. You know, what would be unambiguously legal would be to write your own equivalent of their app to work with the wheelchair. And so if you reverse engineered their protocols to do so, that would be clearly a DMCA cutout. That's probably the way to go. And then of course, once you open source it, people can have a field day and start adding their own functionality to it. Actually, that's probably the way forward.
All right, my first pick this week, something that I've actually seen people talking about. This is an ESP32 dev board from, I guess it's Helltech. It wouldn't be my first choice for my company name, but it's a ESP32, and it's got LoRa, and it's got an OLED display, and it's all in this, you know, all in one thing that you can get pretty cheap, and seems like a great way to get hacking with this kind of stuff. Except, oh no, when you buy it, the documentation and the libraries are, surprise, garbage. I've actually seen people struggle with this specific model on like a couple of, like different discords and stuff, and it just seems like everybody buys it. I think they're, I must say, like $9 or something. Like they're like impulse buy price that people buy it and then they get it home and they're like, well, I can't make anything work, and why is this? And apparently there's like 3 different versions and each one's slightly different, and like the pin numbers are different, and nobody actually documented that anywhere. So I'm glad to see that someone is now taking that challenge on and properly documenting this thing and writing a better library for it. It's kind of a shame that the community needs to do this for a commercially released dev board, but I guess we've seen worse, right?
Yeah.
Just, now with this new library available, and this is for the Arduino IDE, and apparently everything works in it, and not only did it, like I said, not only is there a nice library, but they've actually gone through trouble of properly documenting how everything works and stuff like this, onboard battery hardware, so they look at like the charging circuit and that kind of stuff. It's a very nice deep dive into this dev board, and at least one of its spin-off versions too there's a smaller one that they're also talking about. With this kind of information available, it's only going to help more people do more cool projects with them. So you almost wonder, why make the dev board and release it without this kind of information? I guess they must figure that, somebody in the community will just do it for them, right? They figure, we'll put this thing out and we'll make it cheap enough, and I don't know, somebody will figure it out. I suppose as long as we keep doing that part, they'll just keep releasing the cheap, poorly documented boards, knowing that the community will do free labor, unfortunately.
I think that's a dark view. I think this is, a Chinese module manufacturing company. Their expertise isn't in writing good open source software. Their expertise is in, making cheap hardware and selling it. So,
yeah,
let them do their part. We'll do our part. We put it all together and you get your chocolate and my peanut butter. Like, it's a win all around. You're right that they could have done that work, but if they don't and they make the parts cheap enough, we could do it. I think that's pretty cool. The library it uses, Radiolib, is really awesome. I'm not much of an Arduino user, but I have used this in the past for some NRF24 projects, actually. But I was just now looking at Radiolib, and it supports just a whole ton of different radio modules out there. And if you've ever tried to use them, basically what that means is, you have to look up the data sheets and you have to set some bits here and some bits there and, configure the radio up to run. It's not impossible. It's a little bit of data sheet diving. But if you use Radiolib, someone else has done all that data sheet diving for you and wrapped it up in a nice library. And even better, it's just one library to learn ever. And you can use it with this radio. You can use it with this radio. You can use it with this radio. So I think that's actually really cool, and it sets you up to do like a whole bunch of different modes. I haven't used any of that. I was just using the regular old text across modes, but apparently they have all sorts of pager modes and stuff like this in addition to LoRa and LoRaWAN and et cetera, et cetera. So if you want to do a radio project, you could do a lot worse than to look up Radiolib. That this project is porting Radiolib to this cheap device I think that's, like you say, that's super awesome.
Yeah, actually, I got some little demo code in the GitHub repository for Radiolib, and it does look pretty cool. I haven't actually played with that, but just looking at the code here, it does look refreshingly non-terrible.
Yeah, and this board has a little OLED on it. It looks really sweet.
They even have it's got some buttons on there too. I mean, it's pretty much everything you need to, short of the case, to make some kind of a little wireless gadget. Like I said, it even has the battery charger, and there's connector for a little LiPo, and why build the hardware when you can just buy it and put it in a box?
Hell yeah. Next up, I wanted to wedge 2 projects together because they're both tiny, tiny little projects. And by tiny projects, I mean they work on the microscopic scale. The first of them is Mu RepRap, taking RepRap down to micrometer level manufacturing. This is really cool. It uses the OpenFlexure project's Delta stage, which we've actually seen used as a stage for moving slides around under a microscope and doing that kind of super precise positioning. But this uses that stage as the head of something that's basically like a printer. It's doing tiny, tiny micrometer scale positioning and depositing of material. Here they're using photosensitive resins probably. It's not like you're going to have a nozzle extruding melted plastic on that scale, but you can, micro dispense fluids and have it be useful. That's really neat. This is a sweet little project, and I love the fact that it piggybacks on OpenFlexure's Delta stage, which is also really cool. It's entirely 3D printed, and it's surprising what you can do with a little bit of leverage, right? Move far on this side of lever, it moves very small on the other side of lever. And this is all done with a flexure movement, 3D printed. Really, really cool. Not witchcraft, but the OpenFlexure project has enabled a couple interesting kind of citizen science-y projects so far, and it's nice to see this one, yet another one spinning off of it.
At SuperCon, we saw something with the OpenFlexure, like the microscope. Did you see that one? That was really cool. It is really impressive what you can do, like you said, just with some 3D printed parts and some steppers.
The next one that I wanted to twofer in here, which was measuring nanometers at home. This is another tiny, tiny scale one. This is making your own Fabry-Perot interferometer. When light passes through like a liquid or a film, the polarization that comes out of the other side of it depends on how thick that film was. And this is actually the same effect that makes you see kind of shiny rainbows when there's oil on the surface of water. And that's because there's a super tiny thin skin of, gas or oil or whatever it is over the top of the puddle. Light goes bouncing through, comes out, spun around a little bit out the other side. That's the same gimmick with a Fabry-Perot interferometer, except you use these kind of pretty color fringes to gauge how far the distance is, how thick the liquid in between the two surfaces you're measuring is. And this is just a sweet little demo of how easy that is to do at home. They're not telling you how to manipulate things at this scale. You're actually just kind of putting these slides as close together as possible. But by looking at the fringes and counting them and figuring out, how many of them you've gone through, you can figure out what the distance is between the two plates. And I just thought that's really cool too. So two kind of low-tech, high-tech science projects in one Hackaday.
All right, well, this next one is called Reducing Seams in FDM Prints with Scarf Joint Seams. Oh, 2 seams in one. This is, in a way, a blending of like the old school and the super high tech. If you've ever printed anything almost, but especially anything like cylindrical on your standard FDM desktop 3D printer, you've probably noticed that the point where a line starts and ends, makes this little nub, and they will occasionally align themselves, so you have this kind of unsightly seam right down the middle of your print. And different slicers have ways of hiding this. There's like a randomized seam thing where they won't all end up in the same spot, and that kind of helps, but you still have these weird little inconsistencies that, like, if there was a corner you could hide it in, it wouldn't be such a big deal, but in a cylinder or something that you want like the surface to be very smooth, it kind of takes away from that. So this is an interesting idea that apparently has been proposed for Prusa Slicer and Orca Slicer, and is something that's being worked on. And it uses the idea of making a scarf joint, which is a woodworking kind of concept where instead of two 90-degree angles butting up against each other and making kind of an ugly seam, you cut them both at an angle so that they run parallel to each other for a little bit, and you have these on both sides of the joint, you have these very fine interfaces that you can kind of feather in. And it's the sort of thing that would be done on molding a lot of times, where whether it's like the crown molding or like quarter round or something, you don't want this ugly seam in the middle of your room that you could obviously see. So they'll cut both pieces of the molding at like a 45, opposite of each other, and then they can slide together. So to be able to take what is, an ancient technique, like people have been doing that as long as they've been, putting pieces of wood together. It's, it's a classic joinery thing. And to bring it into like the ultra modern 3D printing world is pretty cool. And I think it's a great example of, how like the classics never die, right? Like the classic tricks are always worth keeping in mind, because you never know how you might be able to repurpose it and solve a very modern problem with an unlikely old school technique.
What I think's really cool about this, so you have to print these two like wedge shapes where the two lines join each other. And to do the bottom one, the one that kind of ramps up into the full bead width, actually takes a little bit of work. Like, you know, you have to drop the nozzle down and extrude very little. And then as you extrude more and more up to your like final extrusion amount, you also are lifting the nozzle up. And then when it does the other part, it just kind of, the nozzle gets to travel straight and it just kind of gloms on there. It just kind of extrudes slightly less and less and less to let it taper off. And then the two joints meet. Totally agree with you that this is one of those applications of a classic principle, but now we can do it in software and on the cheap, and we can do it with every joint of a 3D print. I mean, you know, every layer joint of a 3D print is pretty awesome.
Like you said about the head going up and down, there's certainly been more of kind of an embracing like dynamic layer size and stuff too, which I guess was probably not always easy in like the older slicers. You can make the layers thinner where you need the detail, or fatter where it's just structural. So it's interesting to see that we're kind of getting away from this idea of, you know, a rigid layer height throughout the whole print. So I think it's probably just, you know, the side effect of getting better control electronics and more advanced slicers. We're able to start doing some of this stuff that would have been a tall order in, you know, the old and wooden 3D printer days. And I think too, it's interesting because I feel like we've talked about this exact thing before, but like we often consider like slicers sort of a solved problem, right? And slicers are the slicers, and they're as good as they're going to get. And then something like this comes around where you're like, oh, okay, like there still are stones unturned in what we kind of think is like an arrived finished technology. Perhaps the best is yet to come for your desktop 3D printer. And the cool thing is too, like changes to the slicer on the whole aren't going to require anything necessarily on the hardware side. So, I mean, this is like your desktop printer learning a new trick without having to invest any better steppers or anything like that. It's not like you getting rid of some kind of backlash physically. It was just a limitation of the way that they were slicing. And now with this improvement, you know, assuming it gets more popular and kind of becomes the default, that's just, you know, a software change that is going to make it a super obvious improvement in print quality. And that's really cool to think that there's still more to come, right? Like, I mean, I've definitely printed stuff with that seam right down the middle, and it was like, okay, whatever. It's a bracket or something. It's not super important, but if you can make it go away with literally, a couple lines of code, then why not?
You were talking about the old tricks being always relevant. And if that's the case, our next hack is hyper relevant. That's a lot of building systems. And it's a review article by Eric Hunting of like every building system he's ever encountered. And this is amazing. It's a 71-page document, and it describes each of them. Honestly, you're going to want to take this as an invitation to go down all of these different rabbit holes and look at all these different construction methods. You know, you probably know Lego and maybe grid beam. And if you're an engineer, you've probably used like 80-20 aluminum extrusions and stuff. But there are a million other systems. Well, okay, it's probably not literally a million. Probably 200 other different large mechanical construction systems listed here. And you absolutely want to look through them and have, if you look through this document and familiarize yourself with how all of these things work, you are going to have so many different ideas in your brain about how to mechanically connect things. I cannot recommend it enough. This goes into fancier things. It goes into lower tech things. They actually talk about different ways to build things with bamboo rods, which is interesting because you can buy bamboo sticks dirt cheap and they're really strong and very light. And it's just the connecting of them together that's the hard part. And there's a couple neat ideas here. I mean, they talk about angle iron. They talk about T-slots, all the obvious things. But then also, how to put up a theatrical truss, how to make a dome out of zip ties, how to do various panel things. So all of those panel mounting systems. That's really, what am I going to say? This is just an invitation to spend a good week or two looking at materials and how to connect them together to make whatever it is you want to make out of them.
talk about like a encyclopedic look at stuff to build other stuff. The only thing I can say, and we certainly are not in the habit of putting down anybody's work, but pictures would have really been nice of some of this stuff. And like, listen, there's already so much information in here. I'm not complaining. It's incredible. There's also this write-up of like so many of them and how they work, and obviously an incredible amount of effort went into it, but it'd be nice to be able to visualize these things a little bit. And I almost wonder if this is something that could maybe evolve into like a wiki kind of thing, so that more people could submit images and that kind of thing, or even add. I'm sure there's still more to add, right? There's probably other building systems, and in the comments, some people even mentioned a few. So I could see this certainly being the base of community database of building systems and tips and tricks and that kind of stuff. I think that would be of great use to the community.
Yeah, my take on this is that this is not finished and that this is a document in progress. And
right.
that it's probably going to be added to and edited. But I think you're right that like a wiki format would be even better, because then, everybody could contribute their own things to it. And that would be really cool. And yes, I 100% agree with you that you need images for this. But the reality is, of course, you can just then get the keyword and search it yourself. And I guess that's kind of what I meant by this being a rabbit hole to go down, because all the work is not done for you yet. And if you don't already know what this build system looks like, you probably are going to have to look it up yourself on the internet and see how it goes. That's kind of the limitation here in a way. But on the other hand, this is all of the search terms you need to spend, a good week looking at industrial and hacker-sized build systems.
So somebody in the comments even says, like, I'd be happy to build a website around this if they want.
Please do. I want to see it, and I'll contribute to it.
Yeah.
If you make it a wiki, I will add to it.
And somebody else made a good point, too. Like, something in there, like an idea scale would be helpful, too. Because obviously, like, what you're going to do with Legos versus what you're going to do with 80/20 are pretty different. You know what I mean? Well, this one I liked. It's just like a classic hacky hack, and it is always cool to see that sort of thing. This is a story of a old piece of gear bought for cheap. I think it's something probably a lot of us have run into from time to time, and the risk there, and like what happened, there was a pin code. This is a generator like front panel, and there was a pin code that kept you from getting into the settings, and of course no one knows what it is because it was some device from the 90s that was picked up for a song and changed hands so many times. So Buy It, Fix It decided to open it up and see if he could get the pin code off, and looked around the board, saw a little 8-pin flash chip that I think most of us would identify these days. Pulled it off, read the chip, saw that it was clearly, the configuration, because it had up in the top, it had like, copyright 1998, blah, blah, blah. Wiped it, reinstalled it, and, the pin is gone, right? And the story could end there because his original goal was just to get the pin off and be able to get into the menus. But before wiping the config, he had the forethought, and this, by the way, this is always something you should probably do, is make a copy of what's on the chip and save it before you delete it. And then with that original copy and the now, fresh chip compared, he was able to start finding the different fields for various settings, right? And through like a process of elimination, you change something, you pull the chip, read it, change something, pull the chip, read it. He was able to kind of map out this whole configuration system and even do stuff like it has a running total for like hours run and how many times the generator started and kilowatts produced and that kind of stuff. And he shows how that's converted into hex and then saved, and you can, if you know the number because it shows it on the screen how many hours it has run, you can convert that and then use a hex editor, search for it. And it's kind of just an interesting walkthrough of how you can search through like a firmware dump and find interesting things and map it out, which is definitely a cool technique to use if you've ever had some weird gadget where you wanted to know how it was storing something, or you wanted to fiddle with the settings. It turns out over the course of the video that apparently there was actually like Windows software that you could use to write this stuff right to the chip, but it's for some antiquated version of Windows, you can't find it anymore. So this kind of research would open the door to writing like new software, right, and something more portable if that was what you were into. The only thing I would say after watching this video, I would have invested in a socket for the chip.
Yeah.
Because this chip gets soldered and desoldered and soldered and desoldered far more times than I would have been comfortable. Literally every time he changed like a value in the firmware, he's like, okay, time to pull out the hot air and pull this chip off. So I would recommend a socket or just a clip to read the chip in place. Would have been perhaps a little more efficient. But on the software side, it was really cool to see how you figure that out and how you look at you have the benefit in this case, like I said, there's stuff on the screen like identifiable numbers. So if you have those kind of touchstones that help you navigate through it, it's always very helpful and a good tip to just keep in mind. To be able to pick out certain things and kind of work backwards from there.
Yeah, it's a great tip. I was actually doing that with a wireless thermometer we have. And so, it just sets out a bunch of random bits, right? But if you look at it and see what temperature it is, you've got one number. And then you change the temperature, right? You bring the thing inside and it warms up slowly. So you get a whole bunch of different numbers there. You watch which field changes, and then you see what it says and what it correlates to on the screen. And pretty quick, without any sort of big brain work, just by looking at the diffs of a bunch of different, hex dumps, boom, you've got it done. Those kind of simple approaches will often get you the answer you want. Like if you could change the situation and read out what the resulting data is, you can pretty much always figure out what's going on in the bit stream.
And I think it's probably a good time to plug Bitbench too, if you've never actually used that. We have written about that. I'll put the link in there. It's a really cool, like web-based software for that, where you can, copy a bunch of hex, drop it in there, change something, paste it in, and it'll actually keep track of like fields that are changing and kind of automate a lot of that comparing. And instead of having to just keep doing a diff of like a dump, you can just look at this and see what's changed. Especially like you were saying, for something that's like a thermometer where the number is changing a lot, and you'll have. You can just breathe on the thing and get a bunch of different samples and compare it. It's a really cool tool for that.
Oh, cool. I've never seen it. See, you learn something new every day.
Always got to listen to the podcast. You'll learn something new.
I do. All right, my first quick hack this week comes from Karakuri channel, randomly move marionette with steel balls and Geneva drives. This is a really crazy automata that uses a multi-way funnel that kind of randomly distributes ball bearings down one of 5 different paths. These ball bearings then get caught in teeths of these wheels and make a part of the automata move. But it's really neat that it moves them randomly, because you never know which tube the ball goes down and which gear is going to get engaged. Next up, Home Sweet Home automation entry, simple window closer relies on gravity. This is a project by Gautier. I actually can't tell if he's trolling us or not, but it's a reminder that home automation doesn't always need to be supremely technological. This one's actually a weight and pulley system that he made that closes the windows after his cats go in and out of them. It's got a light enough weight on it that the cat can open the window, and yet it closes after itself. It's pretty sweet. If you've got a more electronic home automation project, definitely enter it into our home automation contest. Here's a home automation project that didn't enter the home automation contest, but should have. Aquaticus, simple optical meters, that's new standards for documentation. This is a little device that fits onto his home power meter, which apparently blinks every 10th of a kilowatt hour or whatever. He reads the blinking and sends the data off to his own home automation network, so he can log his power consumption as well as the state of all of his home devices. And last up, 3D imaging for natural sciences for free. This is just a quick ad for the OVERT project, which includes 20,000 CAT scans. This is CT scans of various natural objects. This is just a superb source of 3D models for whatever. And I remember back in the day when somebody scanned a Yoda head in and everybody put a Yoda head on every 3D printed object. Well, this at least gets you 20,000 different things you can put onto your toothpaste tube squeezers.
My first quick hack is unusual port. It combines DisplayPort and HDMI. Well, certainly I've run into this problem where I had some gadget that's DisplayPort and all I had was HDMI cables or vice versa, and they are relatively easy to adapt one way to the other, but if you don't have the adapter, you're kind of beat. So this is a particularly unusual device that was brought up in a recent video by John Bringus, and it is a Steam box, which was, kind of a whole side thing, but it was a attempt at making, PC games in a console form factor. They must have realized that, the gamers would have all kinds of different displays, so they actually used a connector on the back that is both DisplayPort and HDMI in one, and it's pretty wild. And you kind of wonder, why we don't see more of this. There are some limitations that he goes over in there. DisplayPort and HDMI actually do use like a different signaling scheme, so it's not just a different pinout. But still, I mean, it's really cool to have both in one port, and you kind of wonder why you don't see that used, certainly on gaming consoles at the very least. John thinks he actually found the part itself on Mouser and has a link if you want to try to buy the connector. It'd be interesting to see this kind of gain some notoriety and become more common, because I think it would certainly save people from having to carry adapters around. Next up is Stressless Shortwave Reviewed, and this is a stressless receiver kit. It's a very nice looking receiver, a shortwave receiver. You have a nice like metal case and a color screen, and very, very slick for something that's, homemade. And the review says that their build process is pretty nice and the performance is nice, and then everything is good. It's a solid option. The capabilities are a little bit limited. Like Al says in here, there's no single sideband, and apparently the firmware can't be changed, although, the manufacturer saying the firmware can't be changed doesn't necessarily mean the firmware can't be changed. The biggest problem, I think, to take away here, and like Al points out, apparently it's like 600 and something American dollars. And it's nice, but I don't know if it's $600 nice, So these are one of these ones we'll live vicariously through watching somebody else build it. And then last up is Rosie the Robot Runs for Real. This is just a very fun one. It's somebody's built a life-size, Rosie the Robot from Jetsons. And it certainly looks the part, and it's tooling around the house and vacuuming, and apparently it's made some waves. Even the mainstream outlets ran stories on this. There's not a lot of technical detail, but looking at it, you can kind of see the trick here. It's really a Roomba that's just dragging a Rosie the Robot. It looks like it's an office chair, probably. It's like an office chair with like a body built on top of it. And granted, like the head moves and there's a little bit of like, motion in there, but it is not nearly as advanced as you might think at first glance. But hey, it's a really cool idea, to use the Roomba as the motive force for this much larger and visually impressive robot. So, I mean, this could be something to keep in mind for, Halloween. We always like to see cool builds there. And if you wanted to have some kind of a robotic thing to move around the house, but you didn't want to have to literally build a big robot, this might be one of those classic tricks to keep in mind for the future.
All right, without further ado, let's head on off to the Can't Miss articles. These are fantastic pieces written by our own Hackaday writing staff. This week we both picked Arya's articles. I'm going to start off with Design Review, DPI LVDS Sony Vaio LCD Dev Board. This is the first installment in Arya's Send Me Your PCB Designs and I'll Review Them For You column, which I think is a lovely idea. If you design a PCB, it's always great to have a second set of eyes have a look at it before you send it off. It helps avoid a lot of the simplest mistakes. And if somebody else more experienced / differently experienced looks at it, they can often bring new perspectives, suggest different parts, etc. I think this is really great, and I think it's really brave that a bunch of people sent their PCBs off to Arya for having a look at, and I think it's lovely that we're all getting to learn from this together. So moving on to the board, I agree with Arya that this is a cool project in and of itself. This is Excencio's converter from Raspberry Pi, parallel RGB HDMI, over to LVDS, which is the low voltage differential signaling that drives a lot of laptop screens. So if you wanted to hook a Raspberry Pi to an LVDS laptop screen, this would be the adapter board for you. In looking through it, Arya picks out a couple total rookie mistakes that I think we've all made. One of them, and my absolute favorite, I remember the first time this one got me, was the confusion between metric size parts and imperial size parts. And so when people call out 0603, that's 0603 inches, right? Those are, I guess, they're thousandths of an inch. But if those are then fractions of a millimeter, the part is significantly tinier. And so there were some like microscopic little capacitors, resistors, can't remember, on this board. And Arya was like, hey, what's going on here? Why are you using such small parts? And Exensio was like, what do you mean? They're 0603s. But when you divide by 2.54, they're actually 0201s in imperial, which are, yeah, you sneeze and they're gone. You know, simple mistake. And as Arya points out, KiCAD makes this really easy by, you know, in naming the footprints, they're also named by both the imperial and the metric equivalent. And unfortunately, some of them have the same pairs of numbers. And so it does get confusing. So no shame here. The other changes that Arya suggests are actually not mistakes per se, just ways to improve the board. And I think that's actually the best reason to get someone else to look at your board, is because you may not be doing something wrong, but someone else might know some cooler parts to use or whatever. And here Arya in particular is suggesting swapping out the 1117 voltage regulator, which is, I think, the SMD package of the old LM317. I mean, it's an ancient design for something that has a lower dropout voltage, because then you can use a more modern regulator, smaller parts, smaller capacitors, and have a draw off of the 3.3 voltage rail to generate the 2.5 volts here, I guess. You could draw off of a lower voltage power rail for just all in all less power wasted in this linear regulator. I totally agree with Arya. It's a great idea here. And, you know, it's simple as picking a different part. And honestly, here, the footprints are all identical, so it doesn't even call for a board redesign. You just, like, don't order that 1117, order something else. The other constructive suggestion / addition Arya makes here is to break out all the unused pins into headers. And in particular, this project had one kind of question mark left in it, which was how to power the backlight of the particular LVDS screen that they're targeting here. And it needs a high voltage source to run the backlight. And the question is how to provide that. And Extensio's answer was, that's a problem for later. Arya's suggestion is then break out the pins that would go to that, and in fact break out a bunch of the GPIOs onto, you know, normal 10th inch headers, so that you can make that part of the project later as a daughter board. Because if you're experimenting with different circuit topologies for that, you don't want to redo all the board that you know works already. Instead, just make a little header for it and plug those in as daughter boards until you get that part of the design right. I think that's a really neat idea, to take a design where you want to try out a bunch of different alternatives and, you know, just break that part off into daughter boards so that you don't have to redo the whole thing every time. You can just redo little parts of it. And that kind of makes your PCB design more modular, which means that once you've got one part right, you can then move on to working on the next part and the next part and the next part. And that's super when you're doing something kind of quasi-exploratory like this. Maybe not useful if you're making something that's dead simple and you know it's going to work. But if you've got parts where it's like, make PCB question mark profit, if you have to work on that question mark part, spin it off to a daughter board.
Yeah, who would have thought that modular design would work, right?
Okay. It sounds obvious, but I've never done this.
No, I'm with you. No, it's something that we see elsewhere, right? And we don't necessarily think about for the PCB side, but of course it makes sense. We do it in so many other things, and certainly in code we're reusing modules all the time. just in general, like to go back to what you said about everybody being very brave. Like everyone involved is brave. Like Arya is very brave to be willing to look at these boards and give advice, and the people sending them in are very brave to lay their work down at for this kind of inspection and public discussion. Everyone involved is braver than I. I'll put it that way. I would not volunteer for either side of this equation. So my hat's off to all of them. But it is such a fantastic way of learning, and obviously, no one here is looking to bend anybody out of shape or put anybody down. It's all in the sense of helping each other out and just sharing that knowledge. And there's I know there's actually like some subreddits where you can do a similar thing. You post your PCB and get some critiques. So it's really cool to pull that information, and like you said, you're always gonna always another set of eyes helps for everything, right? You're always gonna miss something. No one's perfect, and especially when it comes to like you talk about like the voltage regulator. I mean, that's some of that's some real arcane knowledge, unless you've been working with all this stuff, you don't have these numbers at the back of your head. I could use this one versus so no, this is a really cool thing. I know that from the back end, she got a lot of people sending designs in. So there's I hope you guys like seeing these.
Yeah.
Because there are many more of these to come, which I think is cool. And
I love it. Yeah.
I think it's awesome. I think it's a great idea for a kind of a continuing series. And yeah, I'm glad that, I was overwhelmed when I saw all of them coming in, and I wasn't even the one who agreed to write them up, so again, definitely a lot of respect for taking this challenge on, and I'm excited to see the results. And also this one, did you mention that this is kind of related to her Sony Vaio remake thing?
I didn't, but now you did.
Yeah. It's kind of this is a good one to kick it off, because if you recall, we covered Arya's work previously to design a new motherboard for a Sony Vaio, I guess, Palm Top or some kind of ultra portable. Someone else was working, this person was working on that same idea and had contacted Arya and said, not only am I working on a similar idea, I'd like to pick your brain about this part I was designing, the display adapter. So it's really, really, really in her wheelhouse, because it was something that she was personally kind of interested in. So it's a cool one to see kick it off. And I was very interested in that project to modernize that Sony Vaio too. So this is like one step closer to that, because now they're and as she mentions it in this write-up, one of the most important things is getting the original display to work, right? It's kind of, almost the product doesn't work unless you can get, like, because her whole thing was she wants to reuse the display and the keyboard and blah, 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 just a drop-in board. And if you can't get a display working, then you don't really have much at all. So this is a crucial element to that coming together, which is really cool.
You said there was a subreddit that does this. I've seen kind of open board critiques in a bunch of other open hardware communities that I'm in. For instance, I did some RC plane stuff, and ELRS is a remote control plane protocol and radio setup, and a lot of people build their own receivers and transmitters and whatever else. And so you see people in the ELRS Discord being like, hey, I'm going to make this receiver design. Somebody have a look at it and sanity check it for me. And this happens all the time in that community. And it's kind of a norm now, where like just anyone who wants to get some other people's eyes on their PCB before they get it printed can just like post up Gerbers and say, hey, does this look right to you? And I think that's really lovely. And, first of all, that person gets great feedback from people who know best about it, but also we all do. I don't know about you. I need reminding to put better silkscreen labels on things. I need somebody to be like, hey, you could have documented this part on the silkscreen, or hey, what value is that? Where does that line go? Which pin is ground? Like there's all these things you can do that you forget because, you're doing the part design or you've got it in the board layout. So it's labeled ground in the software, but if it's not labeled ground on the silkscreen, fat lot of good that does you. So I think this sort of feedback, like I could always use it. I think everyone can. And I love seeing this hobby / open source hardware / the kind of hurdles to doing this kind of development getting low enough that we see communities develop around it, that we then see people saying, hey, give me some help here, look it over, because that sort of stuff used to be, in the past when only engineers for large corporations were doing PCB design, they were doing this kind of review internally, but it never saw the light of the day. And now that we're all doing it, boom, everybody wins.
Well, I think that's a good point too, is that, certainly not all of us, but the majority of us are just, self-taught, working in isolation. We might have read an article on Hackaday or watched a YouTube video on how to design a board in KiCAD,
Right?
and away we went, knowing just enough to get in trouble. Yeah, it is great to just check with other people. And there is so much it's overwhelming, really. So much to know when not just designing the electronics, but also like getting the board right and getting it fabricated. And, you really don't want to have to do it more times than you need to. So you want to try to get it, everything right, so good luck, but you want to try to get everything right that first time. And there's no shame in reaching out and saying, like you said, hey, could somebody take a look at this? And there are plenty of, even if you're not ready for the grand Arya treatment on the front page of Hackaday, there are places you could go. I mean, even in our own, the Hackaday Discord server, we have a PCB design channel that people just drop in and say, hey, I'm thinking of doing this. Does this make sense? And it might still be Arya telling you whether or not you should do it. But at least it'll be, without the eyes of the world on you. Well, I hope you like hearing about Arya and making circuit boards, because this second one is much of the same. This is share your projects, KiCAD automations, and pretty renders. I like this one a lot because, we've all seen, I think, these hardware projects where you go on the documentation and, you're just blown away by, these cool board renders and like interactive bills of material and all this kind of stuff. And how do they do it? Like, what's the trick? What's the software for that? Are they doing it manually? And, and at least for me, I just say, well, it must be too difficult because I'm not going through all that. But it doesn't have to be. And Arya shows some tools here, and I would imagine we'll be showing more in the future, probably. In this case, it's specifically kind of geared towards, like a Git workflow, integrations and stuff. But, this isn't necessarily limited to just using Git. It goes over what you can do in the KiCAD command line, which is really cool. I actually haven't played with that very much, but apparently you can use that to just like make, do make files where you can, generate Gerbers on the command line without actually having to open the KiCAD interface, which is cool if you're, pushing changes to a Git and you want to just do new Gerbers and you don't want to have to, do it all manually. You can automate that kind of thing, which is really cool. Apparently some of this has changed now in version 8, but in at least 7, which is, I would probably imagine what most people are still using, you couldn't do things like you could export 3D models, but apparently not like the 2D SVGs and that kind of thing. So there's other tools out there that can do that, and she talks about that. There's KiKit, and that will make nice export your design into different things, PDF and images, and you can make like a little interactive web page that shows it all. It just looks really cool. I mean, and documentation is always one of these things where that we know kind of falls to the wayside a lot of times. It's not fun. Like to be honest, it's not nearly as much fun to document something as to build it, right? Like we want to build the thing, we want to see it working. A lot of times that's where the process ends, because taking the time to do documentation and doing screenshots and all that kind of stuff it's a tall order, right? Especially for hobbyists. That's not like, nobody's paying us for this stuff. But tools like this can make it a lot quicker, a lot faster. They look great. It makes it very impressive. If I go on to, and Arya talks about this too. She's got, hundreds of open source PCB designs out there already. It's a lot of work to do all those images and documentation if you had to do it by hand. So being able to automate that kind of thing and having like a workflow where you can, automatically generate like a nice SVG of the board and drop it into a page, can really help. And it's just cool kind of a overview of some of the tools that are available to kind of pretty up your projects. And obviously no one is required to do this, right? It's nice. It's nice to see this kind of documentation and these pictures, but there's no, just because you release your thing as open source doesn't guarantee that you're going to do amazing documentation and 3D renders and stuff. So you shouldn't feel pressured necessarily. But if you do want to take your project to that next step and kind of get people excited about it and get contributors, it does help to have a nice presentation. People are going to be impressed and they're going to want to look more into it. And, coming from one of the people who has to write up others' projects, it is a little disheartening to go to a GitHub repo and see nothing, just say like a README that says, hey, here's the board. Seeing pictures and bills of materials and that kind of stuff really does make it seem like a living project and something to get excited about and not an afterthought, right? So things that make that easier are definitely of benefit to the community. And I know after reading this, I'll be taking some of her tips and using some of this software for myself to try to, improve my own documentation and just make things look a little bit more professional, a little bit more less like I did it in my basement.
Even if you did it in your basement.
Even though I definitely did. I don't want you to necessarily think that when you say it.
This is one of those where Arya puts this article out and then a couple days later, the state of the art changes enough that she's like, can I add something to it? And I'm like, we don't ever modify our articles after they print. But yeah, go nuts. Because the command line for 3D PCB rendering got merged into KiCAD 8 like a few days after she wrote this article. That's how fast things are moving. And you focused on the point that automating these tool flows makes it easier for you to produce your own documentation, but they also make it easier to make fancier things too. And it's fun because Arturo182, hey Arturo, took the ability to get the 3D PCB renders out of KiCAD and made a bunch of stills and put them together into an animated movie. And because this is all scriptable, you can actually make easily animated rotating videos of your printed circuit boards, which is cool because it is a 3D model and rotating it gives people a much better feel for kind of the three-dimensionality of it all. So yeah, tons of really cool tools in Arya's write-up here, and they will, I hope, inspire you to either improve your documentation, make funny videos. I don't know what else you want to do with 3D renders of your circuit boards, but definitely avoid making some obvious mistakes where things in 3D space collide with each other. It's totally useful and totally something that should be part of your workflow, and making it as painless as possible can only be a good thing. Yeah, when you look at Gerbers, they're just like, it's just 2D.
Yeah.
But stuff in the world, turns out it has this extra dimension to it. I don't know, man.
Yeah.
I don't know. That brings this week's Hackaday podcast to an end. Thanks very much for listening. If you'd like to reach out to us, tips@hackaday.com is the email address. And if you want to follow along with the links or leave comments on this show, head on over to hackaday.com/podcast. And until next week,
keep on hacking.
Hello, and welcome to the Hackaday podcast.
And on that note, we'll screw up on the first. I think we make our own rules. No one will stop us. You still there? We went out for a while on that one.
That's okay. I wasn't saying anything good anyway. Hotel Wi-Fi, worth every penny. Hello.
Yes. Did I go out that time?
Yoda head toothpaste tube squeezers.
It should be the like the slogan for Thingiverse or something. You hear me now? All right, my get in the right headspace.
See there, if I just say less, it's like saying more.